All right. Hello, everybody, and welcome to the stream. Hope everybody's doing well tonight. Just adjust this a little here. So tonight we are picking up where we left off, plus a little bit. We are basically going to be finishing up with the refactor tonight, which is awesome. We are dang close last night, but we kind of ran a little bit. Ran a little bit too close to quitting time last night. So what I did was I went ahead and did a little bit more just before the stream here and was able to actually tie that up a lot quicker. So we're going to be able to move on tonight, which is awesome. So I hope all that makes sense. Before we jump into the stream, though, I do want to just take a quick second and thank the supporters of the channel, starting with our partners, who are the highest tier of subscription over on YouTube memberships and Patreon. They are Dustin Punt, Gabby Bashir, and Gerboles Inc. I would also like to thank all the other supporters listed here on the screen. They're a combination of the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It means a lot, and it helps me grow the channel and helps me get things like new equipment for the channel. All right. I hope it also goes without saying that I appreciate each and every one of you guys, whether you're here joining me live on Twitch, on YouTube, or if you're just watching the video afterwards. Thank you for being here. This project wouldn't exist without you guys. So with all that said, this is an interactive stream, so if you have something to chat about, feel free to jump into chat, say hello. I do keep an eye on both of them. That is YouTube and Twitch chat. So Spiro, how's it going? First on both sides. That's pretty good, bud. Speaking of Spiro, since he's here, Spiro is Spiridon, I should say, is a GigaChad developer here on Twitch. So I'm going to toss him a shout out. If you're not following him, you definitely should be. All right. Goldenberg Dev, how's it going? Good to see you. Whoa, Mac development. Yes. Although we're not really going to be developing too much on this tonight because it's actually done. Yeah, no problem, Spiro. So basically what we're looking at here is I just wanted to kind of go over the last few things that we had to change. And really it wasn't that much. We had it, like, I would say probably 80 to 90% of the way last night. So really what we are looking at for the most part is, let me switch my keyboard here. There we go. So really what we are looking at is primarily what was in the Vulkan platform macOS. So we had to basically fill out this stuff, the platform-specific stuff for Vulkan. So this is basically the layer where the platform-specific layer and the Vulkan-specific layer meet. And so that's why this is in a separate file. The big difference between this platform and the other platforms is, according to the Vulkan spec, all surfaces for macOS actually have to be capable of presentation. So that is part of the spec. It's guaranteed. So we actually don't have to run any sort of check on that here. We can just simply return true. In fact, there is no check to actually run, right? So that was kind of a nice little thing, right? And I put notes in here detailing as to why that is. The last couple things we had to do were all in the platform macOS, and most of it was just around kind of continuing to move things surrounding these objects here. So this, the delegate, the handle, the view, the layer, and device pixel ratio. That was another change that we kind of briefly discussed last night, was this device pixel ratio, where that needed to be moved to be Windows specific. So it is part of the Windows state now, as opposed to the actual platform state. And so we've actually updated the functions for all three platforms to use the window instead. So if we go to platform H, and we get device pixel ratio. We can see here it's part of the, it's also part of the K window, which is part of a feature change that I want to make. And I kind of put a pin in this, right, just to kind of move past the refactor. I'll do this in the next version, but eventually it's going to actually wind up in the actual K window struct as opposed to the device or the render platform state, right? So the other change was here in this function signature. The platform device pixel ratio now requires a window, right? And so when we go to make that change, it'll be nice and easy to make and move that to sort of the front end of the window interface. So, all right. So with all of that said, we are actually in really good shape. I think I already built, but let's go ahead and build anyway. All right, and we're just going to swap over to the editor that shall not be named for our debugger. And we'll run this real quick. And in case you're wondering why it's not showing up on the terminal, on macOS, it shows up under the debug console, all of this stuff. I don't know why that is. It's got to be some sort of weird platform-specific issue for Mac. But yeah, that's more or less what the issue is there. All right, so what we are looking at is, here's the application, right? So we see that our UTF-8 headers now work, or the Japanese kanji shows up, so we can use UTF-8 characters in our title bar now. That was actually something we kind of got for free on macOS, but not so with Windows, right? So that was another change that I made, and I'll show that on Windows here in a bit. But let's go ahead and load up a scene, and we'll see some changes here as well. So one of the changes I made was to add a second layer of this text that's colored black, and render that behind the white text so that no matter, if we're over a light area or a dark area, we can kind of read this text a little bit easier. And you also notice that I imported a new mesh, right? Because I got kind of tired of looking at the same ones. And I'll likely add a couple more to this. But, it's kind of like a Viking little house thing, right? And so, we still have our Sponza here, right? Everything looks pretty much as it should. All of our rendering modes work. So if we go back here, and I switch to lighting mode, we can see that, right? It looks pretty good. Now, the Sponza does have some issues with it. However, I believe that this is an issue that is actually more so with the mesh itself. It's just that the metal sort of layer that Vulkan is being translated to is actually highlighting this issue. But the actual issue is if we take a look at the normals mode here, we've got some invalid normals here. That's why they're showing up black, right? So the way that I have these normals set up is even if the normals are in a negative direction, I'm taking the absolute value when using the when rendering the color, right? So obviously one of these normals along the z-axis would be positive, the other would be negative, but they both show up blue because I take the absolute value of that, right? So we've got a few faces on here that just have invalid sort of normals on there, and so I think that is why our lighting is showing as it is. You'll note that on all of the other meshes, the lighting is just fine, right? So everything is looking pretty good, I think. It runs nice and smoothly. We can take a look at the shadow cascade maps here. All of these are working correctly. We have our PCF filtering back for our shadow maps. So everything here is looking pretty good. Even our fade out works for our shadows if we back out enough. You can see that there, right? So there is that. And then our wireframe view works as well as expected, right? we also have all of our debugged shapes showing, right? So that is sort of the visual demo to show that we are back up and running on this platform as well. All right, so if we take a look at our app config, we have a few updates here. Most notably, we have a new editor Gizmo node, right? And that's how we get the editor Gizmo to show up. I forgot to show that off, actually. Let's bring this back up. All right, and we'll just load the scene back up. And so I can select an object, and we have the ability to, move it around by the gizmo, rotate it, if I can, there we go, right? Things of that nature. So our gizmo is back up and running as it should be. So that is that. And then there is also, I also fixed a bunch of code in the debug 3D node to actually get all the lines, the grid, all that other stuff to rendered, right? And so we basically just hooked that into our render graph, and now everything works as it should. So I believe I've actually pushed all of this. Let's see. Let's open a terminal really quickly and just see. Yeah. So we are good in terms of git status. So that's pretty much it, right? We've ported all of our changes to macOS. We're up and running on this one now. So yes, we are finally done with the refactor, at least for now, right? So we're going to hop off the Refactor Tractor a little bit. We're actually going to cut a new version of kohi tonight. Get all of this merged into the main branch, which we're basically just going to... We're going to take a look at that pull request because it's going to wind up being massive, right? And you guys will see exactly how large this refactor effort has been. Pro Gaming and Mean Mr. Mustard, how's it going? This is awesome, finally. Yep, exactly. I couldn't have stated it better myself. Let's see. Lou the Coder, how's it going? Beautiful, nice, thank you. Appreciate that. Let's see. David says, first time chat, by the way, welcome. Hi, what are your thoughts on Metal or Vulkan for Mac? So, I have to say that, obviously macOS doesn't support Vulkan natively, right? You have to go through Molten VK. I will say that the Vulkan SDK has made that very easy, and it just kind of works out of the box. There's a few things that you have to do that are platform specific, but it really wasn't that difficult to actually set up. There's not a whole lot of code in the renderer to support that stuff at all. And most of what's in there is in the platform layer. So yeah, I can't really complain about that. Actually, it works pretty well. That being said, it is a translation layer, right? So it basically translates all the Vulkan calls to Metal calls underneath. So there are limitations with that. There's things that you can't use. We've run into those things here on stream. But for the most part, everything has worked pretty much that we need to work. But because it's an emulation or translation layer, I should say, it's never going to be as performant as actually writing just pure Metal code. So one of the plans that we have for this stream is actually to develop a rendering backend in Metal. And so we're gonna actually support that natively in Metal as well. We'll maintain the Vulkan support probably, but we want to use Metal obviously on macOS. So that's going to be the next rendering backend that we tackle. Although we're not going to do that until probably after we ship the first game. So I want to get most of the features in the engine that I want before I go adding additional backends. And Vulkan is kind of what gets us the biggest bang for the buck. So I hope that answers your question. Will you eventually show us how to get gizmos to look like Godot or Blender gizmos with shaders and everything? Yes. So the gizmo that we have now is a very temporary one, right? And if you weren't on the stream when all that stuff was written, the gist of it is, and I'll launch this again. Yeah, it's been going on for 3 months. Yeah. Wait till you see the pull request. All right. I guess I'll select the car here. Right. So we have this sort of, it's a little bit difficult to see, but we have this sort of disabled selection state, right? Where we just kind of highlight that something is selected. And then we have this state, which is basically just lines of geometry, right? It's not actually even triangles or anything. It's just lines that we drew, right? So we have one for each axis, and then we have combinations of those axes, right? So we can use this to go along the local y and x axis, the local y and z axis, the local z and x axis, right? And then we actually, if you go towards the center of it, you can do all three, which basically slides it parallel to where the camera is looking, right? And so we have all the basic functions of it working. There's a couple problems with this though. So this is actually rendered in the scene currently, which means when you back away from it, it becomes smaller and harder to select, right? So that's obviously not optimal. The other problem with this is we are just using geometry here, which is the quick way to put it together. But really what we want to do is we want to have sort of a screen space shader that is positioned where the object selected is, that moves around as the object is moved in space, but it stays the same scale on the screen, right? And we could do that. We could, kind of mess with that here and try and figure that out here. But I think, this was kind of the quick way, but it's not as nice as it could be, right? The lines are kind of thin, so we are going to revisit this. We're going to make the gizmo. We're going to enhance it a little bit. That's the movement gizmo. This is the rotation gizmo, right? So we've got the different axes there. We're rendering the entire circle right now, which is basically just a bunch of lines, right? But that also makes it kind of hard to see a little bit, right? It makes it a little, kind of suboptimal to use, right? And we also have the scale works very similar to the way that the position works. It's just with the combination of axes and all. It's just, it's kind of based on your drag distance is how that scales, right? So there definitely are some things that we want to address with it to make it a little bit more user-friendly, to make it look nicer. This is sort of the first iteration of that. We built it from scratch, right? So we don't have, the tried and true versions that are probably provided by some library that a lot of game engines use. So yeah, that's more or less what we're doing. Okay. Are you doing color picking to select the axis? Nope. Actually, we're doing so. There is in 3D space, there is actually a invisible rectangle that we use, that we hover over, and we raycast into the scene to actually select the different axes, right? And so we use those. I shouldn't say rectangle. I should say what's a 3D rectangle, I guess, right? So there's like a long, skinnier one that goes for each one of these axes. These are sort of like flat sort of squares, so to speak. And then there's sort of a cube that sits here in the center. And based on which one of those we are actually interacting with when we do a raycast into the scene, that's what one highlights. So it's actually using proper raycasting into the scene to accomplish it. And I wanted to do that because pixel or color selection has a lot of issues with it, right? One of them being, what if you have, if your camera is positioned like over a red light or something, and the colors are very similar or even exact, then that breaks, right? So we obviously don't want to do that. So we opted to do the world space raycast on that. All right, let's see. Speaking of the first game, are you starting it next stream? Probably. We're actually going to go through a planning phase, a bit of a planning phase, figure out all the list of features that we want to add, and I'm actually going to have chat pitch in a little bit on that. with any ideas that you guys have or that things that you'd like to see implemented in it. We'll talk about that when we get there. But yeah, we are going to probably start scaffolding that structure next stream. So let's see. It's cool to see you working on this. I worked on a Gizmo feature recently as well in my custom engine. Yeah, it was a pain to implement. It was a lot harder than I thought it was going to be. I guess it was a lot more code than I thought it was going to be. I had to do a lot of research on how other gizmos, sort of accomplish things. And when we move things around, that's actually raycast too. So we actually we create these invisible planes in the scene. So that way, as we, when we select an axis and we're, let me do movement instead of scale, actually. So when we are moving along an axis, we can move the mouse wherever we want on the screen. And the way that it is able to maintain where it's supposed to go is it basically follows the distance on that invisible plane in the scene. In this case, that is parallel to the axis that we're actually moving, right? So there's all kinds of little tricks and hacks like that. Like when we do this one, it actually creates a plane that's parallel to the camera in the scene, and that's how we move it back and forth. So yeah, it was really quite an interesting exercise to make that from scratch. I'd never actually made one from scratch before, so that was really a lot of fun. Okay, so there is one thing that I'm considering doing, and we might not do this until we actually get a little bit further into the engine. But one thing that is missing is we don't have shadow maps for point lights, right? So if I move the car here, which a light is attached to the back of it, we don't see, this section here shouldn't be lit, right? So, there are some things like that we're going to have to address, but let's see. In terms of retaining gizmo size, the way I approached it is that I project the 3D position onto a plane that's a fixed distance from the camera, so the size stays consistent. Yeah, that sounds like a good solution. But I want to change the way that these are rendered anyways, because I'm using lines to render these, and that's not great. I should probably be using like actual geometry. If you get the chance, maybe you can read Max Liani's blog post on his Gizmo designs for inspiration. I might have actually read that. Let me see. Oh, no, this is different from what I read. Okay, I'll take a look at it, though. Thank you for that. Appreciate it. I have it opened in another tab. Okay, so the plans for today's stream is basically to... So I've battened down the hatches for macOS, and I've already pushed that. So what I'm going to do is I'm going to re-verify that everything builds and runs on the other two platforms. Fix any issues that come up, which I don't think there's going to be much, if anything. And then once we've verified that works on Windows and Linux, we're going to go ahead and cut the new version and get that in. And then we'll just kind of go from there to see if there's anything else that comes up as we're kind of playing around with it that we want to fix. And then next stream is probably when we'll start the game. All right, so let me close this. And we are actually done on here for now. So what I'm going to do is I'm actually going to switch. I'm going to switch on the new machine that we built on stream last week. And I think just to avoid any weird issues, I'm going to use, let's see, I guess I'll use the ad screen. Right, we're not actually running ads now, but just while I switch sources here and wait on this machine to boot. Shouldn't take very long at all. I gotta switch keyboards and stuff too. So the next thing we're gonna do is we're gonna verify this on Windows on the new AMD machine. What is the reason to develop on macOS initially? Actually, we didn't. macOS was actually the last platform that we supported. It was added pretty late in the series, actually. So what I've done was I actually got everything working on Windows and Linux. But there were some changes that I had to make to those platforms that I didn't realize I had to make until the Mac was being redone. So let me just switch this over. Let's see, which one was that? That was... So yeah, we didn't do it initially on Mac. We just did. Okay, well, I guess I could do Linux first while that one's booting. Let me just move a couple things around here on screen, and then we can switch back. Let's see, let's get this one over here. And let's see, where is my... I don't even have a terminal open. Okay, well, we should be able to just use this guy. All right, so let's go ahead and switch back to this. No source. Okay, neat. I think I'm probably going to have to refresh this, I guess. So I guess let me switch to the camera and then switch it back to that. There we go. Okay. OBS gets a little bit weird about switching input sources sometimes. All right, so what I'll do is we'll do a git pull. All right, and we're going to do a clean build. Enter Travis 10 coupon code to get 10% off any product that would agree to sponsor us. That's funny. From Lake, how's it going? Good to see you. You're streaming and I'm still on my PC. That's not good. I'm still deep. Oh, geez, you're in the weeds with PHP and MySQL, huh? Oh, that's no worries, man. Do what you got to do, right? Okay, so everything built successfully. So let's go ahead and run this. All right, that's what I was wondering. So there were some issues around this business here. Oh, it's because I copied this and it shouldn't have been copied. Keyboard, hello. Okay, for some reason, my backspace just does not want to work on my keyboard. Don't quite understand that. All right, let's rebuild that again. One error generated. What is the error? Nothing. Wait a minute. This doesn't belong there. There we go. Okay. This is precisely the kind of stuff that I wanted to test before we actually push. Okay, so it looks like our UTF-8 stuff isn't working here. I'm okay with letting that slide for now, but we do need to fix that. Let's go ahead and load a scene here. So it looks like everything on Linux works well too. You just cycle through the same views. Yeah, everything seems to be in good shape here. Let me try wireframe. Yeah, okay. So that all looks good. so that's good. That's 2 out of 3 platforms. So what we'll do here is we'll just check this minor change in. All right, so push that fix. And it was very strange that this operates differently per platform, but speaking of, we have ads. Speaking of platform. So for those of you who are new to the channel, we do pause whenever ads come up. We do that so that nobody misses any content, right? Let's see. Let me move this. Couldn't stand looking at the ad screen with any ads. You had to make one up. That's funny. Love the barn. First time I'm seeing it. Yeah, it's actually like a Viking little house thing. I just found a free model online. I got tired of looking at the same models, right? So I threw another one in there. At some point, obviously, we're gonna build a proper scene, but I'm not really gonna bother with that until we start actually making a game. Let's see. How did you approach building the macOS platform layer? I've found compared to Win32, the documentation is quite lacking. Yeah, especially with examples. So actually the very first iteration of it was actually contributed by a viewer. And I was able to take that and sort of run with it. So he did a decent amount of the foundational work for that, and then I was able to take that and expound on it and look up how to do things. And I basically was learning Objective-C while I was doing it. So yeah, it was quite the task, but it involved a lot of Googling and looking up examples of existing platform layers. So that's kind of the answer, right? I just kind of did stuff and tried things until it worked. Because you're right, the documentation is super lacking. Yeah, no worries, From Lake. No worries at all. All right. So we're done with this one. The next one we need is Windows. So I'm going to switch back on the ad screen again. Except I'm not going to push my automatic button because, right, we're not actually paused for ads. It's just, I need that up for, thinking the machine here is doing updates or something. All right, I'm going to reboot my my main PC. Hold on. Oh, I bet I know what the problem is. I'll bet it's I bet it fell asleep while I was waiting. Because I'm not getting a signal. So let's take this guy. This is what happens when you try and hook like multiple machines up to the same card, right? The same capture card. Gets a little bit iffy sometimes. All right, did it pick up on the thing yet? I guess not. Give me 1 second. I'm just going to check the connection real fast. is 3. All right, let's see if that did it. Nope, not yet. There we go. Okay, now we got it. So let's do this. So here's the new machine. So let's switch the keyboards. We'll use this guy again, just as sort of our debugger. Right, we'll go ahead and clear and build. Wolfcraft, how's it going over there on YouTube? Good to see you. All right. Yeah, so this was one of those things that I had to sort of refactor from the macOS perspective. Let's see, we have just one. Oh, we have 5 errors. Okay, so let's take a look at that. It's platform specific stuff. Window. Okay. So do we have? We actually need to do this. Oh, wait a minute. Oh, it's W. Shouldn't be window. It should be W. And then platform state. I suppose I could use. Oh, we hadn't made this change here yet. That's why. So this actually belongs in the window platform state for now. Right, and then this is going to be the same thing. I think that's it. Leonard, how's it going? First time chat, welcome. How are you doing tonight? Did you wind up streaming? I hope I'm pronouncing your name right, by the way. All right, what is this bleating about? Conflicting types. Really? How is this a conflicting type? Oops. Keep hitting the wrong buttons because I'm not used to this editor. Oh, forgetting the K, that's why. There we go. Pretty good. No stream today. Just coding off stream. Nice. Sometimes that's the best way to get things done. That's why I was able to get my Mac platform layer ported. Ruche, how's it going? I am saying it correctly. Okay, cool. Good. I always feel like I'm butchering people's names even when I'm really not. Okay, so we built successfully. So we have... Wait, why is this bleating? What is this complaining about? Oh, I guess it's not. Okay. So we have Mac OS working. We have Linux working. Now let's test Windows. All right, started up fine. Our UTF-8 stuff works here. So this was a big change that I made to the Windows platform offline, by the way. I converted everything to use wide character strings in the Windows platform layer, right? But that change is specific to the Windows platform layer, so that we don't have to use 16-bit characters, right, or UTF-16 all over the place. We're just using UTF-8. So let me load this up and see what we got. And it looks pretty good, right? Yeah, we're doing pretty good, right? We're rendering at 4K here. We have some optimization to do, but all of our stuff here looks pretty good. Let's change our stuff over to like lighting mode. See how this looks. It's not looking too bad, right? You know, we got the Sponza here. That's looking pretty good. Here's our normal mode. That's also looking pretty good. Here's our shadow cascade render. That's looking pretty good. So we've got that. And last but not least, our wireframe mode. That's looking pretty good as well. So all in all, I'm pretty happy with where we are. And I'm going to say that this version of the engine is ready to be cut. So we'll go ahead and do that now. I noticed you only testing if debug builds run. Have you checked release builds for, on all platforms? Or so we could try that real quick, right? That's a good point. I did try it off camera, but I've also made changes since I tried it last. So let's see. So I need to do I actually have a task set up for that in, you know what? Let's do build release. Actually, I don't want to do that yet. I want to do clean first. Then build release. Looks like I missed something in the render graph. Let's see. Oh, this becomes a no-op in release builds, so it's bleating about that. Okay. Well, all right. I guess what we can do is just change this from debug to info. I was official. Thank you for that. I appreciate that. Oh crap, I did a debug build again. Clean. I forget I have to use a different file for that. Okay. Let's see. Oh, editor Gizmo. This is something that I messed with as well. Let's see. That's interesting. Why is it complaining about a struct tag here in a release build, but not a debug build? This isn't a pointer anyway, so a struct tag isn't going to get me anywhere. Oh, I'll bet that I'm probably getting an include through line 3DH that I need for that. Specifically, that one, which we always need. Let's change this. We moved a lot of stuff around, so I'm not surprised that like little issues like this exist. How was the macOS port? You fell asleep yesterday. Yeah, we're done with it, actually. We actually just switched over from it. So we've tested this on macOS and Linux before this. Now we're testing it on the new Windows machine. And now I'm just going to test a release build real fast to see how that runs. 3-stream streak again. Nice. Appreciate it. Are you doing this for fun, or is it a production grade engine? It's not production ready yet, no. I mean, it's mostly for educational purposes, but we are actually going to make games with this. So that's actually kind of what we're gearing up to do on the next stream, right? I'm just testing a few things on this stream. I don't understand why this is hung. It's hanging on creating the logical device. Only on a release build. That's interesting. So I may have some work to do. I'm probably not going to like troubleshoot that here because that's kind of a waste of time to do on the stream. So I will probably fix that offline. But what I will do is I will come in here and I'll put it under the 0.8, right? Because 0.8 is most likely what we're actually going to release against at a minimum. So there is some work that we need to do within 0.8. Not necessarily all this stuff. Some of this stuff might get bumped out to 0.9, but actually it's, yeah, creating logical device. So I'll just put a to-do in there so it doesn't get lost. And then let's clean one more time and build. Okay. All right, so let's just launch this one more time. Just make sure it works. We should be good to go, but yeah, okay. All right, so we're all set with that. So what I'm going to do is Win32 fixes release build fixes. All right, so that code is up. So what I'll do now is, let's see, am I actually logged into GitHub on this box? I don't even know. If I can type. I am, okay. All right, so this feature reorg is the branch that we've been working on all this time. So we're going to compare and do a pull request, but we're not going to do it against main yet. we're actually going to do it against 0.7, which is the current version we're working on, right? Able to merge. So this is the major on stream refactor from the past couple months. See changelog and to do updates for details. All right, we'll go ahead and create that. And the reason I'm doing this is just for traceability, right? So in case you're wondering, this is the list of commits for the refactor. In case you were curious, that's just the list of commits. If you're wondering the scope of the refactor, right? Files changed 574. Big boy refactor, right? I don't even know if this is actually going to load. It should be interesting. So I'm not going to scroll through all this because we'll be here all night, right? But yeah, this is the list of files that have changed, been added, deleted, or changed. Halfway through the list. Now, admittedly, we did also do a restructure for this. So there is that as well. Right? But still. A lot of work. Clone the engine thinking those commits were already up. Nope. You're testing using a separate DLSO for each renderer you create. Seems like a cool idea. Yeah, that makes sense. Trash can, that makes sense. Totally. All right, so here is that. So what we're going to do is I think actually, instead of doing it this way, I could just actually go back to this page. And since it's me, I could just squash and merge. Should I squash it? Or should I keep this? I don't know if when I merge this, if I squash it, if all of these commits individually get held or not. I feel like they still might exist here in the PR, but yeah, screw it. I'm going to do it that way. So there's the commit list. Merge it and close. Delete branch. All right. So now everything is into 7.0. Now what we're going to do is we're going to go to code. And 0.70 had changes. So we're going to create another pull request to take 0.70 and merge it into main. So this is so that, when you clone the repo, you're automatically on main, right? So this is all of the stuff for the refactor plus the other things that we did in 0.7 initially. So we'll create that. Wait on this to check. Is it compiling on Linux? Yes. Compiles on all three platforms. It does look like there's an issue with release builds, but I'm okay with that for right now. We'll fix it in 0.8. Trevor Smith, thank you for the sub over on YouTube. Appreciate that. Merging is blocked. Oh, that's because it requires an approval, but it doesn't require an approval when I do it. So yeah, you can see here, like, here's all the stuff that we did in all of it. Yeah, okay. So there was one PR I accepted actually as part of this. So that was this one here. But other than that, yeah, I did censor out the editor. Yep. Forgot I did that. All right. So let's see. Did I leave the other branches? I think I did. Yes. So I'm not going to delete that branch. I'll leave it intact. I started creating these branch numbers at 0.6, right? So now we have 0.7. 0.7 is now into the main branch. So at this point, I need to do a new tag, and I can never remember how to actually do that. Get add tag. I always have to look it up. I should probably automate this, but is it literally just get tag and then... Yeah, I think it is. Red Swan, thank you for the follow. Let's see. Annotated tags. Yeah, I think this is actually what I'm going to want. Because my other tags are 5 and 6, right? So I need to tag 7. So to do that, I'm going to go back here. Go back to the main branch. Pull all that down. All right. Right. And we're going to do 0, 7, 0. You just make sure I'm formatting that correctly. v0.6.0, v0.7.0. There we go. Okay. Version 0.7.0. All right, so get push. So now we should have... How do I push the tag? Let's see. I figured I could just do that. I don't remember how to do that either. It's something I have to... Wait, okay. This is it right here. Get push origin tags. I think that's pretty much... There we go. Okay, so now on here, we have a new tag for that. Perfect. So what I'll do is, now we're going to do get checkout new branch, and we're going to call this v0.8.0. And then get push u origin v0.8.0. Right, and that is going to be the new branch that we work against. So now it shows up here, right? So that's more or less how we're going to manage versions in this. And the reason I keep these old branches is because if for some reason we have something cut against this version, right, like 0.7, like if we made something against that and I needed to hotfix it, I can go back to this branch off of that one, make a 0.7.1, right? Hotfix branch, and then cut a release based off of that. So that's kind of the idea there. Get push tags. Yeah, that was it. Yep. Yeah, new version. Yep. So yeah, we're finally there, right? Okay. So I guess let's see. We should probably think about what is in here. The fixing release I'm not going to worry about. We do have some changes that I would like to make at some point. But I'm not sure how much of this stuff is actually going to matter for the creation of our first project. So let me just make sure there's nothing critical in here. We have some duplicated platform code. We know about that. That we should probably split out at some point. Not really relevant right now, though. We have ads as well. Simply never make bugs. Yeah, exactly. We have no bugs if no bugs are ever reported, right? Kind of like you have no sickness if you don't go to the doctor. I wish it worked that way. I really do. Got 20 seconds left on ads, and then we'll be able to continue. All right, we are back. So what we're going to do, I guess at this point, let's just kind of go through this really fast and make sure that we don't have anything here. So change render graph to gather required resources at the beginning of a frame. That's probably not a bad idea. Again, we don't have to do that right now. Separate color buffer to its own texture separate from the swap chain, and then blend it to the swap chain image just for present. We might actually have to do that one for when we add post effects. That one probably is going to have to be done somewhat soon. We should be able to switch this for performance reasons on mobile. Okay. Material system refactor. Support multiple pipelines. Standard pipeline, which is... Oh, okay. I don't know if I'm going to do this. We'll have to see. Shader config specifies what pipeline it uses, which determines its attachments. Right, again, we might not wind up doing that. Convert material configs to KSON. Right, so we sort of have this... we do have, let's see, our test bed. Right, so our material configs right now kind of look like an INI file, right? Which is sort of the old way that we kind of handled stuff. So we should probably convert that to KSON, which if you're not familiar with what that is what our app config is, which is a little bit similar to JSON, but it's like our own sort of version of that, right? And again, we did that as a learning exercise, so that might be a good thing to get in, but not necessarily required. We have to convert all these systems to use handles. I don't know if I'm going to bother with that right away either. And then we have a bug here for material map declaration order. Should not matter in config files, but it seemingly does. So that we are going to have to fix at some point. But there is nothing in here that's stopping us from making a new game project, I don't think. So I say we go ahead and we'll start scaffolding a new project, which we're going to basically model after testbed. But it's going to be like a stripped down version of what's in testbed. So we'll see kind of how that works out. So right now our testbed application has an assets folder of its own. It has the application code, and then which is basically just a just an entry point, right? Did we get rid of all the dead code out of here? No, not really. So we should probably do that as well. Right? Don't need that. We don't need that either. Okay. But yeah, all the application is basically just loads all of the function pointers for the application itself, and sets up some file watchers for dynamic reloading. So we'll probably make a copy of this for our game library and just maybe do some of this file watcher stuff only in a debug build. And then testbed has a whole bunch of other stuff in it, a lot of which we might wind up taking, but it's actually... Oh, these are deprecated. These are like dead. I don't remember why I kept those. I must have had a reason, but it's not going to include that. We may move this stuff over just for ease of creation. Okay. So to do this, let's actually do this. And we'll actually do new folder. Let's see, what should we call this? I don't really have a name for the game yet. I guess we could just call it game, right? That seems kind of lame, though. That's what I'm going to go with right now, though. Let's call it Z game, so it goes all the way to the bottom. And we're going to call this .assets. So we need an assets folder. Part of the reason I'm doing this on stream, by the way, is so I can document the process of creating this. And any sort of pain points that we have, like doing this stuff manually, we can automate this stuff at some point. So we need the lib, and then we need the zgame application. Okay, so in this guy, we need a new source folder. You know what? I'm actually going to do this in here. All right. So the assets I'm not really too worried about. The source, I'm going to create a new file here, and we're just going to call this, I guess, main.c, or what did we call it here? I think it was entry.c, actually. Yeah, it was entry.c. And then we also, let's go ahead and actually copy the compile flags as well. So in this case, we want zgame kapp source. We're going to take the kohi core and runtime libraries. That's all we should need for that. And the rest of that's good. Okay, so we have compile flags for that. We also are going to need compile flags for this guy. And we want to create a new, a new folder called source. And again, like I said, we're going to kind of model this after testbed, right? So we do have a version.txt. Do we want to bother with that? I'm not going to bother with that, I don't think. Okay, so I guess we have testbed main here, right? So I guess I'll go with, we'll create a couple things here. We'll do zgame main C. We'll need a zgame main H. And we'll want a types file too. So zgame types. Okay, and then we can kind of expand from there. And then assets. So there is a bit of a conundrum with assets, actually, that I just thought of. And that is, we have certain of these assets are like base assets that should be included with the engine, right? So the one that immediately comes to mind is shaders, right? So all these shaders are here. These are all like standard shaders, and actually some of these are for plugins. So we might want to rethink about how we have some of these things distributed here. We may want some sort of system where maybe the engine actually holds, maybe the engine runtime actually has its own assets folder, so that not everything has to come from here, and then maybe we have like a process that pulls on all of that stuff into our assets folder, right? Not 100% sure what the best way is going to be to do that. Let's see. What kind of game do you want to make with your engine? So we're going to make a couple of games. So the first game that we're going to make is an arcade style game. We'll talk about that here in a minute. We're going to keep it very simple, just as a exercise for the engine, right? To see how it feels writing game code against it, loading up assets, figuring out issues like the one we just found, right? And really just kind of put the engine through its paces, right? So that's the main aspect of that one. This might be silly, but will you add support for custom splash screens? I don't see why not. We should be able to do that. I'm running a new Mac port on my M1, and all is good. With a small hiccup, had to comment out some code on the platform layer, but works now. Do you have the latest that I just pushed to main? Because yeah, if you let me know what that issue is, I could probably fix it. Because my Mac is a M1 as well, so I'd be curious as to what that is. But I'm glad you're able to run it. It could be possible to embed all GLSL shader code into the ASODLL kohi engine runtime library. That's an option, I suppose, right? I suppose instead of doing it from here, we could embed it. Something I was thinking of doing that maybe I ought to do before we release this first game, and actually I don't even think this is on the to-do list. Yeah, okay. Nope. Okay. So something I was thinking of doing is like an asset packaging system where we basically take all of the assets, whether it be from, provided by a plugin, whether it be provided by, testbed assets or wherever it comes from. And as part of our build process, and maybe we do this in debug builds optionally too, there's a process that runs that basically takes all of the binary data from all of these assets, right? So all of our shaders, our scenes, our models, our materials, everything, and basically packs it into one huge binary blob. And then we basically would have a lookup table within that binary blob that says, well, each file exists starting at this point. And then loading assets is done out of that system or out of that binary blob as opposed to direct off a disk, right? That might be something that we have to handle. Because if you think about it, like really hot reloading stuff, like hot reloading assets is something that would be done in an editor, but you don't want that in your runtime. Like your your end runtime game, right? So I think maybe we ought to change the runtime to actually, instead of accessing files like this, maybe we change the runtime to do that. That might be a good project for us to actually look into. Let's see. 2 weeks of PTO. Why make a game when I can refactor the particle system again? I feel that. So technically, you now started the game. After 3 years, there's a huge movement starting with just a few views on YouTube. Yeah, exactly. So yeah, this has been in progress for a while, and we say we're starting the game, right? We're starting to scaffold it and see, we're starting to kind of pick apart issues that we're going to have to run into and solve. And I knew this was going to happen, but it couldn't happen until we actually start thinking about the thing, right? So can you give a brief rundown of your shader system? Does it take GLSL at runtime, generate SPIR-V, or do you compile offline and ship binary shaders? So it does take GLSL at runtime and generates SPIR-V on the fly for now. And the reason I did that is so that we can hot reload shaders for testing, right? The logic for that does technically exist in the Vulkan renderer. It has to, right? We might wind up offloading the hot reload portion of that to the application, though, right? So maybe the shader loading aspect of it exists in the runtime, but the hot reloading is going to have to be moved eventually. That exists, I think, both in the renderer and the shader system at the moment. So ultimately, when we go to ship this, we're not going to want to ship GLSL shaders and compile them, right? We're going to want to, at least for Vulkan, we're going to want to generate SPIR-V and put that binary blob into our giant binary blob. So that is something to think about too. I guess let's go to the top of this. Let's see, we have engine general. I guess we could add some sort of priority stuff here. I'm going to put it above these version specific things because I don't know when we're going to ship this, but we're going to need asset packaging system, including package build process. And as a subnote of that, let's see, assets specific to runtime or plugins should be provided with or at that level to the package build process. Okay, so there's that. And then also for release builds, compile shaders to bytecode, SPIR-V, and place into package binary. All right, so we're going to have to do that stuff as well. Let's see. Does occur on the new main branch. On window, did change screen on the Mac OS platform layer. For the K window, pointer W. Bad memory access error. Weird. Okay. I'm going to make a note of that. What did I do with my... Yeah, there it is. I'm going to make a note of this. Okay. Just so I don't lose it. If you comment the whole block, it works. Okay. Now, if you were to take that window and drag it to another screen, if you have multi-monitors, does that work after you comment that out? Let's see. Yeah, that's a very clever way to do it. I was experimenting too on creating a binary asset pack with an index at the that the engine loads first, then performs lookups with offsets where the assets actually live inside the blob. Very cool and stuff, indeed. Yeah. So it's like a Doom engine WAD, if you think about it. Except I'll probably name it something besides WAD. I don't really quite know what I want to call it yet, but we'll get there. All right. Yeah, because I really don't want to have to like take all of these shaders and duplicate them for every project, right? That sucks. Not to mention that list is going to be changing with like the engine version. So, okay, so I'm thinking if we move these to different libraries, how do we then, because I think the first working version of this is going to have to do it on disk. So for those of you who were around when we initially started this project, we had a process that would copy out of an assets folder into the bin folder for us to actually load the assets. We ran that, I think, every build, or maybe there was a post build or something like that. But it took a little bit, right? Because you're copying a lot of files. So maybe we have another like packaging process that the first iteration of that just moves it on disk, and then the second iteration of that retrieves it otherwise, right? Works with that binary blob. In fact, maybe we could even have an interface. Ooh, this is actually better. So I'm thinking that the engine should probably have an interface to a package. And then the guts of that package implementation would either pull stuff from disk or pull stuff from the binary blob, depending on what you're doing. And that would be hidden behind an interface that the engine itself knows nothing about. And that way, we could just slide under a new implementation and not have to change the engine when we do that. So would provide an implementation, or an interface rather, to the engine, and the implementation could either load from disk or binary blob. Right, so the first iteration of that would basically just point to files on disk, and that would make it a lot easier and quicker to put together. So this is actually gonna wind up being pretty important. We're gonna have to do this sooner rather than later, I think. Only have one monitor, so I can test it on multiple different screens. Okay, yeah, I will look into that though, because I do have a multi-monitor set up here, so I can try that. Thank you for letting me know about that though. You're on the latest version of macOS and all that stuff? Thank you guys for the follows. I appreciate that. Welcome. I just use plain old zip files. That's, I mean, we could do that too, right? We could certainly implement some sort of compression with this, right? This might be an interesting thing to make on stream too. The question is, do I build the game? Do I start like building the game, or do I do this first? As much as I want to start building the game now I'm questioning this. Because I don't want to wind up in a situation where I have to like move a whole bunch of asset code around. Not Sequoia yet, but will soon. Okay, fair enough. Thank you for the hydrate redeem, by the way. Do this first. Yeah, that's kind of what I'm leaning towards. This is a good thing to make, right? So, all right. Let's bust out a this, right? Oh God, is there a dark theme for this? I don't see one. I thought I had this on dark mode. Let's see. Here we go. Much better. Sorry about the flashbang. Want to hear a joke about drinking water? Well, you can't, because hydration is no laughing matter. I love it. It's true, though. It's honestly true. Okay. So I guess let's see. Is that should do. Okay, so I guess what we need to do is I just kind of want to lay this out. So let's say that we have kohi runtime, right? And then we have, let's see, what else provides assets? So we have the kohi runtime has like default shaders. The kohi plugin well, let's see, does any of the, yeah, the standard UI has its own assets, right? Let's see. What else in here has its own assets that are fonts? That's kind of like our default fonts can come with a runtime. Scenes, models, that stuff is all going to be the game. Shaders come with a runtime. Terrains, textures, that's game. Sounds is also game. So realistically, yeah, that's it, right? So this is going to be right, I guess we'll use zgame.assets, for example. And then we'll also have testbed, right? So these are all the things that can provide assets. And so essentially what we need is we need a way to have an asset package, right? And so I guess, whoops, why did it do that one as separate? All right. So I guess we'll have a Z game. Actually, let's do testbed first. So testbed dot asset pack, or maybe just .kpack. There we go. That's what we're going to use, right? This is our asset pack for testbed, right? I guess let's turn that a different color. So we'll have that, and then we'll have another one, which is for Zgame. Right, and the idea is ads. Dang ol' ads. Worst timing ever, right? I mean, actually, it's not the worst timing ever, but Bezos has got to make his money. I'm just adding a few other things to our little chart here while we're waiting on ads. You just figure out how I want to do this. We're almost done with ads, by the way. Got about less than 10 seconds left on ads. Tennis Caden, thank you for the follow. All right, cool. So let me just maximize this real fast. All right, so we have Zgame here, which has its own little, sort of assets. And then we have the testbed here, which has testbed assets, right? But its build process is basically going to have to use pre-existing assets from the runtime. Let's see, how do we do this? Let's put this one here. Yeah. We're going to have some crossover here, but I guess that's okay. So we're going to have to take that one, and then the ones from UI standard, if we wind up using it, right? Those have to go there. And then the assets from, deselect. And then for testbed, the assets from testbed assets have to go here, right? But then we also have these assets also go to Zgame as well, right? And then Zgame assets also goes there, right? So you can kind of see like this overlap that we have of how we kind of need this stuff to be set up. And then the way that this works is Zgame itself, and thus the runtime and everything else that it calls, will pull everything that it needs from this package. Now this package could simply point back to the folder, the assets folder, right? Or it could be existing in the actual package itself. And we could probably control that with maybe a build flag or something like that. And so the first iteration of this would basically just be a facade, and it would have pointers back to these different folders. And that's how that would be managed. Things are serious when a whiteboard pops in. Yeah, exactly. Dingus Dev, thank you for the follow. I love the name, by the way. Are you familiar with dingus-oriented programming? Which is a thing we do on stream here. I have a YouTube short about it, actually. All right. So yeah, I guess this makes more sense to build first, right? I guess this is kind of what we need to start thinking about. Sounds like I'll fit right in. Awesome. Well, welcome. Yeah, we do dingus-oriented programming here, which is you know, it's where I make stupid mistakes on live stream, you know, while I'm programming, and then stumble over it for 20 minutes, and then smack myself in the forehead and go, "Oh, what a dingus!" That's dingus-oriented programming for you. Okay, so I guess what we really need to do here is, I mean, we can keep this stuff for now, right? We've got a small scaffold here. We don't have to necessarily set up the build process for that stuff yet. Because yeah, I guess this is really the next feature that we need to build, right? So I guess we'll call this, we'll call them K-packs. And I'm thinking the way that this is going to work, right, is a K-pack, right, is essentially going to be a container where we have, oops. Oh, I didn't mean to change the color of that. I was going to draw another box and then change the color. So we'll essentially have a bunch of files, right? So I have a listing of files. Yada, yada, yada. You guys kind of get the point, right? Get rid of take this one, move it up here. Right. And then what we'll have up here is a table of contents, right? So the table of contents will contain pointers to all these files, right? So this is, you know, file 0, file 1, etc., right? I guess we'll do file 2. And then we'll just ellipsis this and get rid of all of these, just to simplify things. All right. And so our table of contents will be sort of the header of the file. Or should it be the footer? No, it should be the header. Because if it's the footer, we're going to have to push it out every time we add new files. Okay, so I guess what we could do, well, I guess it doesn't really matter, right? Because the table of contents is going to grow in size too. So either we reserve a certain amount of memory, but then impose a maximum amount that we can hold. Or we rebuild every time. Maybe we rebuild the package every time a file changes, right? Maybe that's the way to do it. And so this sort of is driven, I guess, by a KSIN file, is what I'm thinking. And so a KSIN file contains like a manifest of all the files that go in here. We use that manifest to grab all the handles to the files, which we can then determine the size of the file on its way in, and we could also use that to read all the file contents, get a offset and a size for the file, and then write it to the table of contents. And then I guess we could basically just hold a list of binary blobs, keep a running list of strings for file names, or I guess we could call them file headers, so it would be the file name, offset, and size. And then once we have all of that built out, then we build the binary file. That makes sense to me. And we just repeat that process every time. Makes the most sense to me, I think. All right, so I think that's what we're gonna wind up doing. Johnny Marler with a raid of 61 viewers. Thank you so much for the raid. How are you doing tonight? Welcome, raiders. What did you get to? What did you get up to on stream? I can't say that I'm familiar with your stream though, but I'm going to give you a shout out, and I'm going to follow you myself. But how is it going? Hope all is well. So allow me to, let's see, doing some Windows Dev, Win32 bindings, and a vector graphics editor. Ooh, that sounds pretty sweet. I'm glad I followed you. Definitely going to tune in for that. That sounds awesome. So what we are doing here is we are building a game engine from scratch using C and using Vulkan as our initial rendering backend. I say initial rendering backend because we have plans to support Direct 3D as well as Metal. So the whole thing is basically built as an educational exercise. It started off as kind of a tutorial series on YouTube. We changed formats a few different times, just trying some different things. Ultimately, it wound up landing on the live stream format. And basically, what we do here is we are exploring the process or a way to build a game engine, but in an educational sort of way, right? So I try to include all my thought processes, debugging, all of that stuff here on stream. It's basically the resource that I wish that I had when I was learning how to do this stuff, more or less, right? Thank you for the follow, by the way. So more or less, we are completely, we started from scratch, as in like creating the repo and everything. We've been at this for a couple years because I just do this on my off time. But the engine is available on GitHub. We actually just completed a huge refactor. But it is available here on GitHub, and it is Apache 2.0 license, which basically says that if you want to use this engine, you can use it either independently or commercially, or however you want. All that I ask is that you say that you use Kohi, right? There will never be any licensing fees or royalties of any kind. It's free and open source. Like I said, it's an educational resource, so I want to keep it free and available as much as possible. It is cross-platform compatible already, so it currently runs on Windows, Linux, and macOS desktop environments. We do have other platforms planned for the near future. We are going to support mobile. I'd like to get this thing on the Switch at some point, and maybe some other consoles in the end, right? And so yeah, there's this kohiengine.com is the main website here. Let me see if my bot actually works tonight. But yeah, kohiengine.com is basically the central portal for this. So it's got my YouTube, Twitch link, Discord, GitHub, Patreon, all that good stuff, and it's got my my Twitch stream here at the bottom, right? So I can wave to myself and get Inception there, right? So yeah, that is basically the gist of it. And what we're doing now is we are preparing to actually make a game using the engine, our first game using the engine. We've been at this a while, but in scaffolding our project, we kind of discovered some issues. One of those issues being we don't have a consistent way to handle assets between projects, because there are various systems here that provide their own assets. Plugins can provide their own assets. And so we need a way to very easily, kind of manage those assets. And that's kind of what we're talking about now. So I hope that makes sense. 100 people, yeah, Pog, definitely. Yeah, so yeah, if that interests you guys, I definitely would say please toss me a follow. It helps me a lot grow the channel, and the more people I reach, I'm hoping to inspire people to actually dig deep and write game engines, right? We don't have enough competition out there. There's the big three basically, and there's some other smaller ones out there as well, but the more people that are doing this stuff, the more competition is out there, and I think that's a good thing. That drives ingenuity, right? So yeah, I hope all that makes sense, and welcome. I should also mention this is an interactive stream, so if you guys have questions or anything that you want to bring up in chat, feel free to jump in and I'll answer them to the best of my ability. So to give you guys a little bit of an idea of where we are, I'll actually just run the engine really quickly. And this is going to be running, going to get over the breakpoint. This is going to be running using what I call the test bed, which is sort of our harness application that we're using right now. It's our driver for the engine. And so we've basically just, whenever we load up, we've got some basic UI elements here. All this stuff was built from scratch. And then when we load up, we have just a basic scene here with some very basic PBR lighting. It's got some issues and things we've got to sort out. But we do have, a decent little renderer going here, right? And we also have the ability to not only view it in fully lit mode, but we can also view it in lighting only mode, right? We've got our Sponza model over here as well for our testing, right? We have a normal mode, which shows the normals, renders those out for us so we can see any issues going on with that, such as this Sponza actually has some normal issues on the outside here that are black. So it's just another debug view that it kind of allows us to pick apart stuff like that. And then we also have a shadow cascade debug view where we can see the different cascades colorized there. So we have cascading shadow maps. And then we also have a wireframe view as well. Right, so we've got a whole bunch of different things going on, right? And of course, our normal view. And in terms of engine structure, let me just minimize some things here. All right, so in terms of our structure, everything that starts with kohi is basically part of the engine or a plugin to the engine. So that's essentially what is eventually going to wind up being shipped as the kohi engine, right? Right now it's kind of a mono repo just because it makes it easier to develop. Eventually we will split these things out. But the crux of it is the kohi core is basically where all of our containers, our string processing, our math, allocators, our parsers, our platform code. So this is where the platform specific stuff exists for like Linux, macOS, Windows, etc. Our threading, our time, our basic utilities, some basic types, things like that. That's where all of that exists, and that is separate from the runtime, which is what the application typically uses. So the runtime itself has some basic application interfaces here. The audio front end, the renderer front end, which is the sort of the renderer API agnostic version of the rendering system that the rest of the engine is concerned with, and then the renderer backend is basically Vulkan or what have you. The audio is very much the same way. We have an OpenAL audio plugin, so the audio front end exists in the runtime. Just like the renderer front end exists there. And then we have basic plugin types here, some graphs for like hierarchy, stuff like that. We'll be adding to that as well. And then we have our various engine systems in here, like our material system, texture system, timelines, lighting, job system, all that good stuff. So that's kohi runtime. And then we have plugins. So this engine is being designed with a plugin architecture in mind. In that the application can actually choose what plugins it wants to use and which ones it doesn't. And so the renderer itself is a plugin, the audio system is a plugin, and even the UI system is actually a plugin. So the UI is, we're calling this a standard UI. This is a retain mode UI. And we're also going to wind up having a immediate mode UI. So we're going to be developing both of those. But this is a retain mode UI. And so that's a plugin. And that contains like your buttons, your text boxes, things of that nature, panels, that kind of thing. And so the idea there is the reason it's a plugin is because your game might not necessarily need that, but an application such as an editor will. And so we want the option to include this, but it shouldn't be necessarily required to include that if you're not going to use it, right? And so that's the idea there. And you can also include things and exclude them based on the type of build. So if you wanted to use the debug dropdown, the Quake style debug dropdown that we have in here, that's part of the standard UI. You could use that in a debug build, but exclude it on a release build if you wanted to, for example. So we have that. We have the audio OpenAL plugin. That's obviously a backend for that. That may change per platform. Same with the renderer plugin for Vulkan. Eventually, there will be a Direct 3D and a Metal version of this as well. So the application can actually choose based on build criteria or even just configuration of the application what it wants to use. And then we have some tools here that are like build tools, things like that. And then finally, we have what we call the testbed, which is that driver application that I was showing you. And this is what we use to test new features. And so we have the application itself. So the application here is very light. It's just a single C file that you see here that basically loads up the game library or the game code, right? So the application itself is very small. All it does is basically bootstrap things. The library itself is, you can think of the application code or the game code. And the reason this is split up from the application itself is because this is hot reloadable. So you can actually compile this while the testbed is running, and it will auto reload that. And so that's where all of that lives, and then the assets for that project live here. And so this bit with the assets is actually kind of what we're talking about and breaking down tonight. So what this graph here represents is what I'm thinking of as the solution to this problem. So if we take a look in our assets for testbed, we have a few things here that are provided by the core runtime as well as a plugin, right? So our fonts and our shaders, most of our shaders anyways, are actually provided by the runtime, right? But we just have them all kind of jammed in here under testbed assets. Those things should be provided by the runtime. And then two of these shaders in here, or just, I guess, is it two of them? There's just one. The standard UI shader that's in here should be supplied by the standard UI plugin, right? So if you're using the plugin, it gets included. If you're not, it doesn't, right? And so the idea here is that the runtime should be supplying its own assets, the plugins should be supplying their own assets, and then each project can also have its own assets. And so we have the testbed here, which is our driver application. We have this Z game here, which is sort of the new game project that we started to kind of scaffold just to kind of get a feel for it. Basically, what this chart represents is we're going to be creating these packages, right? So what we want to wind up for the testbed is a testbed.kpack is what we're going to call it. And basically what this is it's a combination of the testbed assets and then the plugin assets and the runtime assets, right? So we can see the arrows going here to those things. And then the Zgame kpack is basically the same thing, but for the Zgame. And then it's also plus the runtime plus the UI standard, right? And so what each one of these things will look like is it's basically a huge binary blob, or at least that's the long-term goal. And it'll have a table of contents with an asset. It's basically an asset lookup table. So there will be, the name of the asset, and then a byte offset into this massive file, and a size. And so we'll essentially have a manifest of all of the assets across all of these things that'll be used to construct one of these. We'll build out a table of contents, input the binary data of each one of these files into here. And then that way we have a very easy way to actually look this up. And you ship the assets all as one big binary blob. And then also, if we build this with a proper interface, we can also have, instead of using a binary blob, we could have this interface point back to the assets folder, for example. So in a debug build, if we want to have asset hot reloading, we can have it point to an asset on disk instead of using one of these. And then when we go to do a release build, for example, we can run a new process that we're going to make that will actually construct one of these as part of that build. And then that build will actually utilize this, right? That's a lot of words. I hope all that made sense, that huge information dump there. But if you guys have any questions, feel free to jump into chat. All right, I'm gonna hydrate here. Okay, so thank you for the follow. So one thing that we're doing on this stream is we kind of design things on the fly, right? And the reason we're doing that is because I want to fully go over the design process, the thought process of what I'm thinking, because I think that that's kind of valuable stuff, right? So thank you guys for the follow. I appreciate that a lot. That means a lot, so thank you. So we kind of landed on this name KPack, which I think I'm going to stick with for kohi pack, right? I think that's going to work. So I think we're going to call the interface as well a KPack, right? Or maybe a K package. Yeah, K package is better in terms of code. So in code, we'll call it a K package. As far as the actual file name and the extension, we'll call it KPack. Thank you for the stretch redeem. Appreciate that. I think that makes the most sense, though. Incidentally, since we have a lot of new viewers here, we are going to have ads in a couple minutes. And so just a heads up on that, we do pause the stream for ads. And the reason we do that is because it sucks to have a full screen ad come up on a programming stream, right? So to avoid that, to avoid you guys missing anything, I pause the stream whenever ads come up. So it's usually up to 90 seconds every 30 minutes on Twitch. And so whenever that comes up, I'll throw up an ad screen with a timer on it, so you know exactly when we're coming back. So if you guys need to go and get some water or something, you know how long it's going to be before you need to be back. What key would you look your asset up with? Hang on a second. Since it loses its path, kind of. So are you talking the like the version of it that references something on disk? Is that what you mean? Because if it is, we were talking about the sort of extra piece that exists here. I suppose I should put it here, right? This bit here is a manifest file, right? And this is basically just a file that in plain text lists all that stuff out. So what each manifest entry would actually contain would be the asset name, right? Which is not necessarily a file name. So it'd be an asset name. And then it would be a file path to that asset, right? So that would be where it is on disk relative to where the manifest file exists. And then it would be... well, I guess we wouldn't have to have... We'd probably only need those 2 bits in the manifest file. Because the offset in this file and the byte and the size in bytes would actually be determined when we open the file to do this operation. So the manifest would really just include asset name, which could be anything, and then its path on disk, right? And so when we go to actually build this guy, if we build the version that looks up files on disk, we would retain that file path. And instead of building out all of this stuff, we would just basically point it to the file on disk. Versus if we build out the full binary blob, then we don't need that file on disk anymore. Does that make sense? So you'd only really build this binary blob like... Speaking of ads... So yeah, if you guys need to go and get a drink or something, go for it. We'll be back in just over a minute. All right, we got about 20 seconds left on ads. Almost 30 seconds, actually. Then we'll be able to continue. Almost done with ads. All right, ads are dead. Okay, just started following along with the Kohi stuff on YouTube. Thanks for being such an awesome resource. I appreciate that. Thank you for the kind words, and thank you for following along and joining us here. I appreciate it. And welcome. Okay, so let's think about this for a second. So I guess if we should probably design this manifest first, right? So I'm thinking it's going to be a KSON file, which is, for those of you who are new, that's a custom file format that we developed here on stream with a parser and everything. So I guess we'll do, as part of the testbed assets, we'll go ahead and let's create a new file here. We'll just do testbed as the first example, right? And we're going to say manifest.kson, right? And so this is going to be, structured like this. This is what the KSON file format looks like, right? It's very similar to JSON, with a few minor differences, right? But as part of the educational nature of this, we developed the lexer and parser and all that stuff on stream. So I guess what we could do, I'm trying to think do we need any header level information? I don't really think we do. Although I suppose, so we could have a files array, right? And then each file would have, no, we should probably call this assets, right? Right? So each one of these would have a name, right? So that name could be any like free-form asset that the user wants it to be. So one example of this that I've seen in like Unreal Engine and whatnot is sort of using the dot nomenclature to sort of signify like a namespace or grouping or something of that nature. For example, we've kind of stuck with a similar naming scheme here. So if we look at shaders, for example, we have this, built-in color 3D shader. And so maybe we'd call it like something like that, right? Or maybe it should be maybe just shader.color3D, right? Or maybe we call it runtime.shader color3D. It doesn't really matter, right? All that matters is that the engine itself has a reference to this. But I'm not going to do runtime assets here. What we are going to do is like specific assets to the testbed. So we want to do assets that are in here specific to this guy, not these guys. We're going to handle those separately. So I guess, for example, we'll do testbed models, and then we can say Falcon, for example, right? And then we could say file path equals testbed.assets Actually, you know what? Let's make this local file path. Let's just say models vulkan.ksm. Right? So KSM is a kohi static mesh. This is the binary format of our static mesh, right? So we do have MTLs and OBJs here. We have a process that converts those into KSMs. So that when we load up the model in our runtime, it doesn't have to convert that. It could just load it straight as a binary blob. They need to be separated by type, like images, audio, etc., or doesn't matter. I don't think it matters. We could include, I suppose we could include type information, right? So we could say type, equals static mesh. That's a good call, actually. We may need to know that, right? And so this path is a relative path, right? So what we really need to know is we need another like global field up here that would say maybe base path, asset base path. Yeah, that works. And let's call that testbed assets, right? And that exists on disk, right? So essentially when we go to cycle through these, when we go to get the path, we would take this asset base path and combine it with this, right? This would determine the loader, so we actually are going to need that. I'm glad you called that out, because that's definitely something we would have hit. And so we actually have assets there, and then let's see, we also have let's see, how do I want to do this? I guess we could say imports, right? And for each one of these, we could say, I guess, libname, kohi.runtime. And then we'd also do a file path of this one. And this would be up one directory and under kohi.runtime.assets. Right, we haven't created that yet, but that's what it's going to be. So we're actually we don't even need this. Come to think of it. So what I'm thinking of here, Gray Shape, thank you for the follow, is if we have a runtime here, we might not even have, well, I suppose we could have like a kohi runtime assets. Yeah, let's do that. Let's actually not pollute the code with assets. I guess we could do it that way. I'm not sold on this yet, but the idea here is that any of these imports would basically take either our runtime or it would take our plugin or whatever this happens to be, and it would search for a manifest file at that level and then read all of its assets, right? And if that thing also had imports of its own, it would be smart enough to grab that, right? But it would also match on libname, so that way if you already had loaded like kohi runtime assets, for example. So for example, let's do this actually. So we have that one, and then we have plugin UI.standard, because this is going to be another one, right? Plugin UI standard. So plugin UI standard is also going to have a dependency on runtime assets, right? I guess do we do this? It seems like it's going to be a lot of folders. Or do we just have an assets directory under that? Maybe that's a little cleaner. Right, because then we can just do this. So the kohi runtime would have its own manifest file that's located here. And that would essentially add, it'd be like adding in like a drop-in replacement to this assets folder. Or assets array. Does that make sense? That should work. And so eventually what we'll wind up with is once we parse all this stuff out, we'll wind up with just a massive array of these assets that all have file paths. And so our manifest object is really just going to be an array of these guys. And our build process for this will be smart enough to look here. So if we wanted to, we could then, we have kohi runtime, right? And we have the source folder here. We could actually do assets there, right next to it. Just like for this guy. You can add an assets folder there. And so we can actually add things that should be packaged with each one of these. There. So I guess let's do, I'm going to copy these for now. And then we'll remove them out of testbed later. So let's do shaders. I'm going to copy that and paste it into runtime. Assets. And the only, let's see, we want all of these except standard UI, right? Because those are actually provided by a plugin. Right, so the kohi runtime provides that. It also provides fonts. So we've got some default fonts here that we're going to include with that. So let's go ahead and include that there. And then I think that's actually all we need to include by default. We don't need any default materials because all like default materials, default textures, that's all created in code. Even like our default checkerboard pattern is actually created in code so that we don't have an asset requirement for default. Maysaka with a raid of 28 viewers. Hello. Welcome. Welcome, raiders. What did you get up to on stream, Maysaka? Thank you so much for the raid. Oops. Wrong keyboard. Quick shout out to Maysaka. There it goes. If you're not following Maysaka, do it. I believe I am. Yes. So you're working on a custom 3D engine, it looks like. how did your okay, Vulkan ray tracing? Ooh, sweet. That sounds like a lot of fun. Was working on shaders for the ray trace textures and vertex attributes. That's pretty sweet. I'm gonna have to tune in to your next stream if you don't happen to be streaming when I am. That sounds super interesting. So Vulkan, show us what you're working on. Sure. So I will give a quick and dirty intro real quick, just to kind of give you project scope. So we are working on something called the Kohi Game Engine, which is a game engine built in C using Vulkan as our initial rendering backend. So we have plans to support other rendering backends such as Direct3D and Metal. But for right now, Vulkan is what we're supporting. It started off as a tutorial series on YouTube. And then as the series grew, we kind of tried different formats, landed on the live stream format, and here we are. So it is a completely open source engine. So it's free and open source. It's on GitHub. And it is Apache 2.0 license, which means it is available for you to use either personally or commercially. And the only thing that I ask is that you say that you used it. The other thing I should mention is there will never be any sort of licensing fees or royalties of any kind. This will always be free and open source. It is cross-platform compatible, so it runs currently on Windows, Linux, and macOS desktops. We have other platforms planned for the near future, such as mobile, and eventually I want to get it on the Switch as well. Yeah, we have kohiengine.com is sort of the main portal for all of that. We have the YouTube, Twitch links, our Discord link, GitHub, Patreon, all those good things, and then the stream down here at the bottom. And yeah, that is more or less what we're doing. We just finished a major refactor effort across the entire engine. So that was actually merged in an hour ago. And so, actually, rather than showing you some old screenshots, let me just crank up the engine. So we have just some basic things in progress right now, right? So everything here was written from scratch. So all the text rendering, all of the UI controls, everything here was completely written from scratch. If I go ahead and load a scene, we've got some basic PBR in place. We've got some cascading shadow maps, the ability to select objects and move things around. So, we can do that, and we have sort of a bit of a real-time editor in place. And then we also have, the ability to, render this in different modes. So we have our sort of default lighting mode, our lighting only mode, right, which is a little bit easier to kind of understand if you're looking at, our test sponza as you have. And then we also have a normals mode. We have a cascade shadow map view, so we can see the different cascades. And then we also have a wireframe view. And so this is what we've been building. And currently, we are discussing a asset packaging system because we were realizing that we have a bit of an issue in terms of how assets are handled right now. And that basically all the assets are housed in the testbed project, which is sort of our current driver for the engine. And so rather than that, we're coming up with a new system to address that issue. So let's see. So now ray trace things have textures. That's awesome. That was meant to be a "can you homophone," but I failed to stick the landing. Fair enough. macOS support via Molten VK, I assume. Yes, exactly. Which is also the reason we're going to be implementing Metal at some point. Is it opinionated in any way about world scene architecture, or can you roll your own? So that is the way that we have... I should probably preface that with something else in terms of the engine's design. So let's see, do I have everything? All right, so the Kohi core is basically like our our containers, some debugging, math library lives here, our memory, like our allocators, things like that, our parsers for different file formats, all of our platform code, so the different platform code for macOS, Linux, and Windows, string parsing, all that kind of stuff. That exists in the core. The runtime is basically what contains the sort of application base, if you will, the game loop, all of that stuff. It's what stands up all the systems that we have. And then, let's see. So we have our audio front end, our renderer front end. We have various systems that we have in place, right? And one of those systems is a plugin system. And so the renderer front end, for example, is just the API agnostic front end to the renderer that the rest of the engine understands. So it's an abstraction away from Vulkan, for example. And that's to allow us to be able to switch and have multiple backends. And that backend is actually a plugin. So the renderer itself is a plugin. So in this case, we have kohi plugin renderer Vulkan. Eventually, we'll have a direct 3D one, and then we'll also have a metal one as well. And so the audio backend also is a plugin. And so that one is OpenAL for now, but we might wind up with other ones like Fmod and things like that. And then the last point that I wanted to bring up is we have the UI system, which in this case is our standard UI system, which is a retained mode UI, is a plugin. So the core engine knows nothing about it, doesn't have to use it. It's up to the application whether or not you want to use this or roll your own. That being said, we don't have an ECS in here yet, right? But when we do make an ECS, it's going to be a plugin. It's going to be completely optional. In terms of a scene, that is optional as well. Technically, you can render all the stuff on your own if you want. You don't have to use the things that we have in place. The things that we have in place, if I take a look at the test bed, we have a, assets is what I want. We have a what's called an application config. And this is a custom format that we developed on stream, just, again, the educational aspect of this. But we have a render graph set up here with different nodes, right, that all do different things. So frame begin, color, color clearing, depth, stencil clearing. We've got one to render the skybox, shadow map, forward, our forward renderer right here, which is the only one we have right now. And then we have debug, an editor gizmo, and then standard UI, and then frame end, right? So we've set up a render graph that is also optional. You do not have to use this if you don't want to, but you can. Even this knows nothing about scenes, right? We do have a concept of scenes, but even this knows nothing about it. It is up to the application to use a scene if it wants to, or it can build out a list of renderables and just pass that to these individual nodes. And so it's completely up to the application how it wants to actually set all that stuff up and use it. Tech256 with a raiding party of 12. Thank you so much for the raid. A lot of raids tonight. I really appreciate that. Thank you. What'd you get up to on stream? And thank you guys for the follows, by the way. Shout out to Tech256. If you're not following them, do it. The whole idea is to keep things as decoupled as possible, because not every engine needs to even have a scene. Not every engine needs to have an ECS, right? Some projects need that, some projects don't. So we wanted to develop this in such a way where all of that stuff's very decoupled, and you can just kind of build it the way that you want, right? If you want to use kohi as more of a framework than an engine, you can actually do that. The more C streams I watch, the more I want to go back to C. Awesome. I love it. Do it. All right. So I hope all of that makes sense. I know we have some new raiders here as well. I was just kind of going over the engine architecture and things that we're working on right now. So do the plugins consume decoupled data with some sort of pub/sub mechanism or like an ECS query-esque method or something else? So, or is there some sort of fundamental structures that they all share maybe? So we do have this concept of geometry render data, for example, which basically provides vertex buffer and index buffer, offsets, sizes, all that kind of stuff. Provides material information. It's a structure that you fill out and pass over to the individual nodes. I'm probably going to wind up simplifying that at some point in the future. But at this point, you basically fill out a structure that's provided by the runtime, and you pass that over. How you get that structure or where you get that data from is up to you. We have a scene that you can query that will give you a list of those things back, and then you can just hand that over to the the node during the frame prepare phase. And that's essentially what handles all of the scene right now is what handles the frustum culling and stuff like that. But if you don't want to use that stuff, again, you don't have to. You can build that list of things manually. Of just if you've got 5 or 6 meshes that you want to just render them manually, you can actually just build that list every frame or whatever it is that you want to do and pass that over to the individual node, which in this case the shadow pass and the forward pass would be the ones you'd want to pass that to. And there's just functions that you call and you just pass that list over. And that list is built using a what I call a frame allocator, which is really just a linear allocator, so it's super fast. And it's no big deal to stand one of those up every frame because it's lightning fast. All it does is move a pointer forward and a block of memory. So I hope that makes sense. It's kind of a big information dump. Color with a U hurts me a bit, not gonna lie. It's the number of years that I spent working on overseas code bases, and it just kind of stuck. But yes, I mean it's the way the rest of the world spells it. It's the US that's backwards, really. All right. So where we were at. And this is kind of what we're trying to figure out. And actually, I'm going to be ending the stream here in a couple minutes, actually. But just to give a recap of where we're at, we basically have this everything in terms of assets is all dumped in testbed assets for right now, where we really have assets that should ship with the runtime and assets that should ship with plugins, right? And those things need to be provided to the engine somehow. So we're basically going to create these K packages that have references to all of these different things. And there will be a build process that takes in a manifest file. And that manifest file was going to look something a little bit like this, right? So it's got a list of assets that it uses, where it gives the name, type, and file path. And then it also has like a list of imports, right? So it gives the library name and a file path to a folder that contains a manifest for that particular library, right? So there'd be one of these files for the runtime and one of these files for the standard UI. And then it'll basically take all of those things. We have ads. Bad timing on the ads. I didn't bat it away quick enough. Seriously, F in the Queen's English. I love it. What the heck is Kson? So Kson is the proprietary language that we made up from scratch, basically. It's very similar to JSON. I'll re-explain this actually when ads are over. I don't want anybody to miss it. Kson is a VTuber with big bahonkas. Seriously? That's kind of hilarious, actually. Okay, that's pretty funny. So it's the idea is it's supposed to be kohi storage object notation. That's very funny though. That cracks me up. All right, we're almost done with ads, so I'll re-explain this in a second. Okay, so KSON is a proprietary format that we made up on stream. Again, this is an educational resource, right? So one of the things we wanted to look into was how do you create a custom format and a parser lexer for that, right? And so we actually went through the process of implementing that from scratch. And it's very similar to JSON, right, with a few syntactic differences. But the idea is it's supposed to stand for kohi storage object notation, right? And so it's very similar to JSON, except it doesn't require commas all over the place and a few other things. But this is a storage format that we made specifically for configuring things like this, right? We can make our scenes, so our scenes actually are made this way. So if I go in here, our scenes basically look like this, right? So we have some global properties, and then we have a tree of nodes here, right? So it's an array of base nodes where you can have different types of nodes with attachments, in this case, a skybox and a directional light. And then here we have the sponza, which has a transform. Nodes don't necessarily have to have a transform. You'll notice like the environment node doesn't have a transform because skyboxes don't have transforms. That's dumb. And directional lights don't have transforms. They only have a direction, right? So our nodes can actually be parented to one another without having to have a transform. It can just simply skip that node when calculating the transform. And so this is what a scene might look like, right? Where we have a sponza, we have the transform, which is, this is position, rotation, which is a quaternion, right? And then scale. And then we have attachments here. So we have a static mesh attachment. Here's the resource name that it loads. Then we have children. So it has one child node that's called tree. It has an X-form. It has an attachment, which is a static mesh, which is a tree, right? And then we have, a simple hut, a tree, a falcon mesh, and then the terrain, right? So this is kind of what a test scene or test scene looks like. Incidentally, we can actually move objects around in the world and save back out to this format. So we have a serializer and a deserializer as well. And so we developed this storage format specifically for scenes, but we've actually found that we could use it for a lot of other things as well. If you have nodes chained A, B, C, and B has no transform, but A and C do, they're both just relative to the origin, or is C relative to A? C is relative to A in that case. Yep. So it just works its way up the chain. It says, okay, well, if I don't have a transform here, go one up. So that allows you basically to, you can organize things in folders, so to speak, without having to have a transform on it. You can just skip that step if you don't want it. So you can use transformless nodes as groups or common behavior modifiers or whatever else to use. Exactly. Yep. It's flexible. Alrighty. Let's see. Let me catch up on YouTube comments. Have you ever really been so far, even has decided to even go want to do more like, wait, what? KP, if you can reword that question, because I'm not sure what you're asking there. I went the opposite direction from ECS. An entity in my engine is a data pointer and a vtable with about 20 function pointers. I also like the one huge struct for all entity types design philosophy. And that's the thing, right, is this engine doesn't bar you from doing that. Because our ECS system is going to be a plugin, and it's up to the application whether or not it wants to use it. The application can do that as well if it wants. Sorry, you mentioned entity systems and my brain short-circuited. Yeah, no worries. I get that. I'm not really a fan of them either, but I know a lot of people like to work with them, so we're gonna implement it as a plugin. That's a meme. Oh, it is? Okay. All right. So I think this is actually probably where I'm going to call it for tonight, just because I do have to get up and go to work in the morning. So I do want to say thank you guys for joining me here tonight. It's been a really good stream, very productive. We made huge progress tonight in finishing up the refactor. And now next time we are going to finish out building out this manifest, the parser for it, as well as deserializing that into an actual manifest that we use to build a K package and all this stuff. So let's see. I didn't love ECS until I found Bevy, and then I can't go back. Yeah. I mean, I get that, right? But it all depends on what you're doing, right? It's an awesome session. Thanks so much. Awesome. Okay, cool. So yeah, if you guys wouldn't mind though, and do me a huge solid if you haven't already, if you could follow me either on Twitch or over on the YouTube side, that would be a huge thing to me. It'd mean a lot, just because I'm trying to grow the channel, right? Els Dragoon, how's it going? That's so cool you were in here. I appreciate that. If you guys aren't following Els Dragoon, by the way, GigaChad developer here on Twitch. Let me do a shout out real quick. If I can. There we go. Yeah, if you're not following them, definitely hop on board with that, because they're doing some amazing stuff over on their channel. What did you guys get up to, by the way? Are you still working on the NES game? They're building an NES game and the tooling for that all in assembly, 6502 assembly, which is super cool. Basically fought a bug all night and lost. I've had those streams too, for sure. I totally get that. All right, let me find someone to raid. Let's see. Just looking to see who we can raid here. My Discord keeps popping off. Let's see. So actually, let me go to same category. I'm hoping to find like another programming stream. I mean, I see somebody I might raid. I've raided them before, so I just want to see if there's something new that I haven't raided yet. All right, let's do... Where did that go? We are going to raid Jetspell, because he is making a pretty awesome retro FPS that is pretty awesome looking, and he's building it in Godot, and he made a custom BSP loader so that he can load like Quake style BSP files. And the game is looking really cool. It looks like he's working on some animation stuff at the moment. So, but yeah, let's go. We'll raid him and see what he's up to tonight. Thank you guys so much for following me here tonight and being here, hanging out with me on stream. I really appreciate it. Appreciate all the follows. And we will catch up with you guys the next time we stream. So thanks again, and I will see you guys next time.